Access to drinkable water is commonly treated as a fixed utility rather than a variable resource. In most developed regions, water arrives through centralized infrastructure that depends on reservoirs, treatment facilities, pumping systems, and distribution networks. These systems function reliably under normal conditions, but they are not designed to operate independently of environmental stability, energy availability, or institutional management. When water access becomes uncertain, whether due to drought, infrastructure failure, contamination, or geographic isolation, the available solutions tend to fall into a few broad categories. Each category carries a different level of effort, cost, and ongoing complexity. One common approach is bulk storage. This includes bottled water reserves, tanks, or cisterns. Storage requires advanced planning, space, periodic rotation, and eventual replacement. It does not generate water, it only delays scarcity. Once depleted, the system provides no further function. Another approach involves extraction from existing sources, such as wells, surface water, or rain collection. These methods often require permits, physical installation, land suitability, and regular maintenance. Wells depend on groundwater availability, which can fluctuate or decline over time. Rain collection depends on climate patterns and typically requires filtration, storage, and treatment steps. Filtration systems address water quality rather than water availability. They assume a continuous input source and focus on removing contaminants. These systems vary in complexity, but most require cartridge replacements, monitoring, and an existing supply to function. Across these approaches, friction commonly appears in the form of cost, installation effort, technical knowledge, regulatory constraints, or dependence on external systems. As a result, many solutions that offer robustness also demand sustained involvement and ongoing oversight. Aqua Tower is a digital instructional product rather than a physical device. It consists of written documentation and video material that outlines how to assemble a small-scale atmospheric water generation setup using commonly available components. The product does not ship hardware. Instead, it provides plans, diagrams, and procedural guidance intended to allow an individual to construct a water-from-air system independently. The underlying concept is based on atmospheric condensation, a process already used in dehumidifiers and air conditioning systems, where moisture present in humid air is cooled and collected as liquid water. Within the scope of the product, Aqua Tower is positioned as a self-build guide. Its delivery format is digital, typically accessed through downloads or a member's area. The materials focus on assembly order, component placement, and basic operational considerations, rather than on advanced engineering theory. The conceptual framing is practical rather than scientific. The materials do not present themselves as research documentation or as a commercial manufacturing specification. Instead, they function as a simplified construction guide designed to reduce the barrier to entry for non-specialists. Using Aqua Tower begins with reviewing the instructional materials. This includes reading through the written guide and following along with the video demonstrations. The primary task is assembling a device from externally sourced parts rather than interacting with software or performing ongoing digital tasks. Time commitment is front-loaded. Most of the effort occurs during the initial build phase. Once assembled, the system is described as operating continuously when powered, with minimal user interaction beyond basic monitoring. The interaction level after construction is low. There are no daily inputs, schedules, or calibration, routines outlined within the core materials. The system's operation depends primarily on ambient air conditions and power availability. Environmental requirements are implicit. Atmospheric water generation depends on humidity levels, airflow, and temperature differentials. The product materials acknowledge this indirectly by framing the system as situational rather than universally applicable. Indoor or outdoor placement electrical access, and environmental exposure influence feasibility. Repeatability is limited to reconstruction rather than reuse. The guide can be followed multiple times to build additional units, but the system itself does not involve repeated cycles of instruction or programmatic engagement. Aqua Tower aligns most closely with individuals who prefer one-time construction over ongoing management. It suits those who are comfortable sourcing parts, following assembly instructions, and handling basic mechanical or electrical components without professional installation. It may appeal to people who prioritize independence from centralized supply systems and who are willing to trade customization and scalability for a simpler, contained setup. The emphasis is on building once and operating passively, rather than continuously optimizing performance. Conversely, this format is less suitable for individuals seeking turnkey solutions, certified systems, or guaranteed outputs. It is also unlikely to fit those who prefer professionally installed infrastructure, regulatory compliance assurances, or fully automated commercial devices. Those uncomfortable with self-assembly, troubleshooting, or environmental variability may find the format misaligned with their expectations. The product assumes a degree of personal responsibility in both construction and operation. Compared to infrastructure-heavy options such as wells or large-scale purification systems, Aqua Tower occupies a lighter, more accessible position. It avoids permitting processes, heavy machinery, and professional installation. But in doing so, it also avoids the depth and robustness of engineered systems. Relative to filtration products, it addresses availability rather than quality, though within a constrained scope. Unlike storage-based approaches, it attempts generation rather than preservation, but without the scale of industrial solutions. The trade-off is consistent throughout the positioning. The product exchanges depth, optimization, and formal validation for simplicity, low entry cost, and instructional accessibility. It does not attempt to replace municipal systems or industrial equipment. Instead, it exists as a self-guided construction option within a broader landscape of water access strategies. The materials present a single pathway rather than a framework of choices, and the system's role remains defined by its limits as much as by its intended function. The explanation ends here, without extending into evaluation, endorsement, or outcome assessment,